So this is exactly the web application in which we are going to be working today on today's tutorial. This is a pneumonia classifier, and let me show you exactly how it works. So I'm just going to drag and drop an image from my computer, and now let's see what happens. And you can see that we are classifying pneumonia with a 99.9% confidence. So this is exactly the project in which we are going to be working today on today's tutorial, and I'm going to show you every single step of this process, from how to set up this web application up and running using Python and Streamlit, how to use the image classifier, and how to analyze its confusion matrix in order to validate its performance, and most importantly, I'm going to share some super amazingly pro tips in order to improve the performance of your model if something is not working as expected. If you're expecting everything to be super smooth and super straightforward, then think again, because when you are training an image classifier in real life or any type of machine learning model, things happen, and whatever thing happens, whatever problem it arises with your model, with your classifier, you need to provide a solution, you need to fix the problem. And in order to fix the problem, you need to be creative, you need to think outside the box, exactly as we are doing over here. So this is what I want you to take from this video. This is by far the most important part of this tutorial. My name is Felipe, welcome to my channel, welcome to this video, and now let's get started. And now let's get started with this tutorial. This is exactly the data we are going to be using today. We are going to work with a pneumonia dataset, and we will be classifying chest X-ray images into one of these two categories. We are going to be classifying absolutely every single image either as pneumonia or normal. These are the two categories of today's tutorial, and now let me show you a few examples of each one of these categories so you see exactly how they look like. These are a few examples of the normal category, and you can see that we are looking at some chest X-ray images, and these are a few examples of the normal category. Now let me show you a few examples of the pneumonia category. You can see that in this case we are also looking at some chest X-ray images. And I don't know about you, but in my case, I have to be honest, and these two categories, they look pretty much the same, right? I am not a doctor and I have absolutely no medical background whatsoever, so these two categories and all of these images, they look pretty much the same for me. And that's exactly why we are going to be using an image classifier in order to classify all of our images into one of these two categories. That's exactly why we're going to be using an image classifier to tell these two categories apart. So this is exactly the data we are going to be using in today's tutorial, and I'm not going to show you the process of building this image classifier because this is something I have already built before starting with this tutorial. I built the image classifier using Teachable Machine, using this website. And if you're curious to know the process of building an image classifier using Teachable Machine, then I invite you to take a look at all of my previous videos where I show you the entire process of building this image classifier. So if you're curious to know how exactly I built the image classifier we're going to use today, please take a look at that video. I'm going to be posting somewhere over there. Now let's continue. This is the classifier we're going to use today. This is the classifier I have already trained. Pneumonia classifier.h5, it's already trained, it's ready, and we're just going to use it today. And now let's continue. Let's go to PyCharm, because let me show you the PyCharm project we are going to work on today's tutorial. So you can see that I have three files over here. One of them is requirements.txt, the other one is main.py, and the other one is util.py. So these are the three files we are going to use today. Requirements.txt is the list of requirements you need for this project, and you can see we have NumPy, Streamlit, Pillow, Keras, and TensorFlow. So please remember to install these requirements before starting with this tutorial, otherwise nothing is going to work. And then if we move to main.py, you can see that this is the entire process we are going to be coding on today's tutorial. And this is exactly everything we're going to be doing today. This is exactly what it takes to make this image classifier available through a web application using Streamlit. So the first step will be setting up the title, then the header, then we're going to create a widget in order to upload a file, then we're going to load the classifier, and so on, right? The entire process is described as a sequence of steps, right? It's 1, 2, 3, 4, 5, 6, 7, 8, steps. That's all it takes to complete this tutorial, right? That's how simple this will be. So this is main.py, and now let's move to util.py. You can see that here we have two functions. One of them is set background and the other one is classify. For set background, this is a function we are going to use in order to change the background of the website we are going to be building today. So this function is only a detail, like a very meaningless detail, in order to make everything look much nicer and much prettier, but it's not really that important because it's not going to affect the entire functionality we are going to be defining here in this process. So that's why I thought it was a much better idea to just use this function from an utils file, so we don't really lose time coding this function, and we can just use it at the end of this tutorial, at the end of this process. Now let me show you this other function, which is classify, and this is a very important function. And you can see we have a very comprehensive description here in this docstring. You can see we have this function, exactly what it does, and we have all the description for all its parameters. But then if I scroll down, you can see that this function is completely and absolutely empty, right? The only thing we have is this comments over here, these inline comments, and this is also like a sequence of steps the same way we had over here. So the idea is that we are going to be coding this function together on this tutorial, but we are going to do it at the end of everything else. We're going to focus on the entire pipeline, and once everything is ready and once we are happy with this pipeline, then we're going to get back here to the util.py file, and then we are going to code this function and we're going to make the real classification, the actual classification, right? But that's the process we are going to follow in this tutorial. We're going to start here with this process, and then we are going to classify an image. We're going to build the code for this classification, and then at the end we're just going to change the background, because that's going to be like the least important of all the details we're going to be doing today. So that's exactly what we are going to cover on this tutorial, and now let's get started with the main.py file. Okay, and the first thing we need to do is to import Streamlit as st. That's very important, because this is a Python package we are going to use in order to make this process available through a web application using Streamlit. So Streamlit is definitely important. And then the first step is to set up the title, and this is exactly how we're going to do. We're going to call st.title, and we're just going to set whatever title we want. I'm just going to write something like pneumonia classification, right? Pneumonia classification, everything's okay, yeah. So this is going to be the title of our web application, and now let's set the header, and this is something we're going to do, calling st.header, and the header is going to be something like please upload a picture, please upload an image of a chest x-ray, something like that. Or maybe we can rephrase it and something like please upload a chest x-ray image, right? This is going to be the header of our web application, so we're just instructing the user to upload a chest x-ray image in order to continue and in order to classify this image, right? Now let's continue. Now we are going to create the widget we need in order to upload a file, and this is something we're going to do, calling st file uploader. We're going to input two parameters. One of them is going to be an empty string, completely empty. And then we are going to specify what are the types we are going to accept in this widget, which I'm just going to do something like JPEG, JPG, and PNG, right? Which are some very popular formats for images, so I think we're going to be just fine with these three formats. Then we need to load the classifier we're going to use in order to make our predictions. And remember, I already showed you the classifier we're going to use today, which is this one. I already showed you the model, the weights of the classifier we're going to be using today, which is pneumonia classifier.h5, and this is where it's located within this model directory. So that's exactly what we are going to load now. But first we need to make an import. We're going to say from keras.models import load model. And now I'm just going to call load model, and I'm going to specify the location of my model, which is model, and then pneumonia classifier.h5, and this is my model. And that's it. That's how simple it is. And now let's load the class names. And in order to do so, we are going to use this file we have over here within the models directory, which is called labels.txt. And if you're curious to know where this file comes from, please remember to watch my previous video on how to train an image classifier using Teachable Machine, because in that video I explained the entire process, I explained the output, I explained absolutely everything. So by watching that video, you're going to understand where this labels.txt file comes from. Now, going back to PyCharm, this is exactly how we're going to load this file. We're going to do something like with open, and this is going to be model labels.txt. We're going to open this as R, as F, and then we're going to say something like class names is equal to, then we're going to do something like we're going to for A in F read lines, and obviously we are not going to mind the last character because that's a new line character, and that's basically all. But if I show you this file again, you can see that this is exactly how how this file looks like. We have a 0 and pneumonia, and we have a 1 and normal, right? So now the only thing we care about are the class names. So now the only thing we care about are pneumonia and normal. So the way I'm going to do it, I'm going to do it in a very, very generic way. So I'm going to do like this. This value that split the space, right? Remember, we have a space between the number and the word and the class name, and then I'm just going to keep the first value, right? So this is exactly how we are going to get all the class names from this file. It doesn't matter how many they are. This is exactly how we're going to get all the class names, and that's going to be pretty much all. In order to make sure everything works properly, I'm just going to print class names, and let's see what happens. Going to execute this file, and you can see that these are the two categories we are printing, pneumonia and normal, so everything seems to be just fine. And now something we could do to start working on this web application to see how it looks like, we can just run this file, and we should be looking at these two fields, right? The title, the header, and also the file uploader. So let's see how everything looks like so far. I'm going to my terminal, I'm going to clear this, and I'm just going to call Streamlit, and then I'm going to call run main.py. This is exactly how we are going to execute the code we have here, and exactly how we're going to launch this web application. This is exactly the text we have so far, which is pneumonia. Please upload a chest x-ray image, and then this widget we have defined over here as the file uploader. So far so good. So far everything looks just fine, and now let's continue. And now you can see that the next step in this process is to display the image the user has selected, right? So this is how we're going to do it. You can see that we are calling this value, and we need to say this is equal to file, and then we're going to say if file is not known, we are going to do something like this. We're going to define image as image.open file, right? An image we are going to import them from pil import image. This is a function we're going to use in order to read the image the user has selected. And this is very important. We need to convert this image into RGB. Now let's continue. Now the next step is to visualize this image, is to display this image to the user, and we're going to call st.image. We're going to input this image, and then we are going to call this parameter, which is use column width equal to true, right? This is exactly what we need to do in order to visualize this image, in order to display this image. And in order to move one step at a time, let's see how everything looks like so far. And if we go back to the browser, you can see that if I refresh, we are going to see exactly the same mnemonic classification. Please upload a chest X-ray image. And instead of selecting a file over there, I'm just going to select and drag one of the images in my computer. So this is exactly what I'm going to do, and this is going to take a few seconds. Now it's reading the image, it's processing everything, and now we are displaying this image in the browser, and the user is now super happy because it's visualizing the image it has just chosen from its file system. So everything is okay so far. Now let's go back to PyCharm, because now we need to follow additional steps. Now is the time we are going to make our classification. We are not going to make the real classification, but we are just going to call this very empty function in order to get these dummy values and in order to just move on, right? So what I'm going to do is from util import classify, and I'm just going to call this function. I'm going to call classify. I'm going to input the image, I'm going to input the model, and then I'm going to input the class names. And this is going to be equal to, if I go back here, this is going to return a tuple of the predicted class name and the confidence score for that prediction. So this is going to be equal to, I had an S missing over here, this is going to be class name, and then conf score equal to classify image model class names. Exactly what we need to specify according to this documentation we have over here. And remember, we are doing nothing. Everything is fully and absolutely empty. We are just going to get these two zeros. But it doesn't matter. Let's just take these two zeros and let's move on. Now, I'm going back here to main.py, and now let's just write the classification back to the user. So let's continue, and something that's very important, we need to make this within this if, otherwise we are going to have issues. And now we are going to call stwrite, and we are going to do something like, we are going to control the size of the text we are going to print by adding some these values, right? These characters. By adding these characters, we are going to control the size of the text we are going to write here. This is a very similar syntax as in GitHub, if I'm not mistaken, as in the README file of a GitHub repository. So this is where we are going to say something like, we're just going to print the class name. So this is going to be format class name. This is where we're going to write the category we are classifying, and then we're also going to write the confidence value, right? So we're going to make this a little smaller, so we're going to add an additional character, and then we're just going to say something like score, and this is going to be the conf score, right? So this is exactly what we need to do in order to write the classification. And so far we are returning a 00, but actually if this is a class name, maybe it makes more sense to return something which looks like a class name. We're just going to return dummy class name and a 0, right? So we are detecting the class name called dummy class name and with a confidence value of 0, right? It doesn't make any sense whatsoever. This is only for debugging and in order to make sure everything is working properly. So now let's go back to the browser and let's see what happens. So I'm going to refresh. I'm going to load the same image again, and now we should be displaying the image, and we should also be visualizing this new output, which is dummy class name score 0. So everything works properly so far, and if you notice, we have completed the web application. The web application is completed. I mean, the entire structure of the web application is just completed, and the only thing we need to do now is to code the classify function we have over here. But this process is done, it's completed. We have completed the web application. This is exactly why I divided the process into these two files, because this way is going to be much simpler to just focus on everything in the main.py file and then just make the classify function, right? We are just organizing the code. This is a very, very good practice. And I don't know about you, but I'm super happy because this is done, this is completed. And you notice how simple this is, right? So now let's continue. Now we're going to code this function, which is the classify function, and you can see that we also have a sequence of 1, 2, 3, 4, 5 steps. The first one is to convert the image we are getting over here to this size, 224 times 224. So this is exactly how we are going to do it. We need to make an import, which is from pil import image ops, because this is the function we're going to use in order to convert the image we're getting into this size. So we're going to call image ops, and we are going to we're going to call image ops.fit, and we are going to input the image we are getting, and we are also going to input the size, which is 224 times 224. And then we are going to input a constant, which is image.resampling.lan CIDA OS, right? This is only a constant, a parameter we need to input into this function. But long story short, remember, we are just converting the size. We're resizing the image we are getting into this size, 224 times 224. And obviously we need to make another import, which is image. Otherwise it is not going to work. And that's pretty much all. This is how we are converting the image, and the output is also called image. We're just going to overwrite the image we are getting. And now let's continue. Now the next step is to convert image as to a numpy array. So I'm just going to define a new variable, which is image array, and this is going to be numpy.asArray image, right? So we are getting the image, which currently is a pillow object, right? It's an image but in the pillow format, and we're just converting this image into a numpy array, right? And we are using the numpy library, which obviously I need to import numpy as np. Okay, and this is pretty much all in order to complete the second step in this process, which is convert the image to a numpy array. And now we need to normalize this image. So what we need to do, I'm going to define a new variable, which is normalize image array, and this is equal to, we are going to take the image array, we are going to cast it as type np.float32. we are going to cast it first into this value. We are going to take the image and we're going to convert it as float32, and then we're going to divide it by 127.5, right? Remember, so far the image goes from, every single pixel goes from 0 to 255. So if we divide it, we are making absolutely every single pixel goes from 0 to 2, right? So far every single pixel goes from 0 to 2. But if we do this, if we subtract 1, now every single pixel goes from -1 to 1, right? We have normalized our image array. And now let's continue. Now we are going to set the model input, and in order to do so, we are going to define a new variable which is called data, and this is going to be np_array, and this is going to be a shape equal to 1, because we are going to input one image at a time. Then the size will be 224, and then we will have 3 channels for every single image, right? So this is exactly the size we need. An image, only one image, 224 times 224, and 3 channels. And the type, this is very important, is numpy float32. Okay, the same type we have converted our image over here. And that's pretty much all. And now the only thing we need to do is to define that the first element and the only element of data is the normalized image array we have over here. And that's pretty much all we need to do in order to set the model input the data we are going to input the model. And now we have only one step left, which is making our prediction. Let's see how we can do that. We take the model as input. This is one of our parameters, the model. So the only thing we're going to do is call in model, and we're just going to input, we're going to call model.predict, and we're going to input the data we have defined over here. And this is our prediction, right? But now we need to unwrap all the information we need from this prediction, right? We need to get the class number we are predicting, and also the class name, and also the confidence value, and so on. Now let's define a new variable, which is index, and this is going to be the index of the class we are detecting. And we are going to make it like this, and later on this tutorial I'm going to show you another way to get the index of the class we are detecting. I'm going to show you a very pro way to do it. I'm going to show you a much better way to do it as what we're going to do now, right? From now, let's just do it in a very classical way, which is argmax, and we are just going to input prediction, right? This way we are just going to get the argument of the maximum value of prediction. Prediction is going to be a vector with two values, and we're just going to get the argument, the index of the maximum number, and that's going to be the index of the class we are detecting. So from now on, class name is going to be class names, and we are going to input the index. Remember, class names is another parameter we take as input here. And then confidence score is just getting the prediction 0, because we only have one element, and then index, right? So this is exactly what we need to do in order to get the class name, and in order to get the confidence score of the prediction we are getting over here. And that's pretty much all. And now the only thing we need to do is to replace this value and to replace this other value, and that's all, and that's it. So you can see how simple making this classify function is, and now you can see why I have divided the entire code into these two files, right? Because the first step is to complete the process in main.py, which was very simple, very straightforward, and then it's just to code these few lines in the classify function of the util.py file, right? And in only a few minutes we have an entire pipeline which is up and running, and we are just serving this image classifier into a web application using Streamlit, and that's it, right? So now let's test how everything works. Let's see what happens. And now let's go back to the browser. I am going to refresh, and I'm going to choose a couple of images of my dataset to see how it performs. So I'm going back to my file system, and I am going back until my test set, because obviously I'm going to choose a couple of images which are completely unseen data from my model, so we know exactly how the model performs. I'm just going to drag and drop an image in the pneumonia category, and let's see what happens. So we can see that we are detecting pneumonia, we are classifying pneumonia with a 99.9 confidence. So this is an amazing performance, this is amazing. So far the model is performing super well. Now let's see what happens with an image in the normal category. So let's go back here, I'm going to normal, and I'm just going to select an image from the normal category of my test set. I'm going to drag and drop the image here, and I'm going to wait a couple of seconds. And you can see that now we are also detecting pneumonia, we are classifying pneumonia too, and with a super amazingly high confidence. You can see that the confidence value of this classification, of this prediction, is 99.4%, which is amazingly high. So something is going on, obviously something is going on. And now let me show you something. I'm going to show you the confusion matrix of this classifier. This is the confusion matrix. I am sure you are familiar with the confusion matrix. Remember how it works. In the y-axis we have the true labels, and in the x-axis we have the predicted labels. And for example, this number over here, 384, means that 384 images in the pneumonia category were classified correctly as pneumonia. pneumonia, and only 6 images in the pneumonia category were classified incorrectly as normal. But if we look at the normal category, you can see that we have these numbers over here, and it means that only 70 images of the normal category were classified correctly as normal, and 164 images of the normal category were classified incorrectly as pneumonia. So, something is going on with this classifier. And I have been inspecting many different images, and I have been inspecting this confusion matrix and so on, and I noticed that this image classifier is super biased to the pneumonia category. So, long story short, it's most likely, for a given image, it's most likely to predict pneumonia than normal. So, pretty much it's classifying pretty much all images or most of the images as pneumonia, and it's not performing very well for the normal category, right? If we look at one category at a time, you can see that the accuracy in the pneumonia category is something like a 98%, right? Something like a 98%, but if we look at the normal category, it's only a 30-something% or around a 30%. So that's what's going on, right? And I think this is very interesting because this is something that sometimes happens in real life when you are training a model. Sometimes it happens that you have a bias and the classifier is classifying one of the categories which are much more likelihood than the other category. And this is something that sometimes happens when you are building a model. This is something that sometimes happens in the industry, and sometimes it's not very clear why this is going on. Sometimes it's not clear why this is happening. Remember that we are predicting images which are chest X-rays, and as I mentioned when I was starting with this tutorial, when I look at these images, they all look pretty much the same because I have absolutely no medical background whatsoever. So it's very challenging for me to know what's going on with these images, to know what's going on with this data. Maybe if I would have some medical training or something like that, maybe it will be a little more clear for me. But it doesn't matter. What I want you to take from here is that this is something that sometimes happens when you are training a model, and sometimes it may not be very clear the reason why this is going on. If you ask me, and from the top of my head, I will say that one of the issues or something that may be going on with this data, with this classifier, is that the pneumonia category, maybe all the images are more similar between them. Maybe we don't really have a lot of diversity, and all the images which were classified as pneumonia, they are like very similar between them. But for the normal category, I guess that maybe we have a lot of diversity in this category, because normal in this context means that it's not pneumonia, but the patient could be completely and absolutely healthy, or it could be sick but with a different condition, right? So I guess we have a lot of diversity in this category, and maybe that's the reason why the classifier is not learning this class properly. Maybe that's the reason. I don't know. That's from the top of my head. But remember, this is something that sometimes happens when you're training a model, and sometimes it may not be very clear the reason why this is going on. But we are going to see how we can fix this issue. Obviously, we are going to fix this issue. I'm not going to give you a bias classifier. I will never do something like that. So I'm going to give you a solution. It may not be the best solution ever, but it's a good solution. I would say it's an okay solution. I'm going to show you exactly what we are going to do. The way we are getting the prediction, we are currently getting the prediction, is the way it usually goes, right? The way we usually do it, which is just getting the maximum number from the predictions vector, right? We are getting two numbers. One of the numbers is the confidence value in the pneumonia category, and the other number is the confidence value in the normal category, and we are just getting the index of the maximum of these two numbers, right? This is what we are doing over here, and this is the way it usually goes when we are getting a prediction. But this is not going to work in this case, because this is going to give us a very biased classifier. What we are going to do instead is this. We are going to classify as pneumonia, which is the index 0, if the confidence value is greater than 0.95. And in any other case, we are going to classify as 1. This is going to be for index equal to 0, right? So we're going to classify as pneumonia if the confidence value of getting pneumonia is greater than 0.95, and in any other case we are going to classify as normal. And the reason for this is that I have been inspecting many classifications, many predictions, and I noticed that for all of those cases, or for most of those cases for which we are classifying pneumonia, we are getting a super high confidence value. We are classifying pneumonia with a super high confidence. But I noticed that in many of the cases in which we are classifying as pneumonia an image which was labeled as normal, in many of those cases the confidence value of our classifier is not really that high. It's not a super confidence value as it usually happens when we are classifying as pneumonia something that is pneumonia. You see what I mean? I noticed that in many cases for the misclassifications over here, for many of these misclassifications, many of these 164 images, the confidence value of our classifier wasn't really that high, right? Not in all cases, because we also have cases like this where we are classifying as pneumonia something that's normal and with a very high confidence value. This is happening too, but in many other cases the confidence value is not really that high. So if we make this change, we are going to be classifying as pneumonia only those cases, those images for which the classifier is super confident is pneumonia, and in any other case we are just going to say it's normal. This is a very atypical way to make a prediction. This is a very atypical way to make a classification, right? The way it usually goes, you just take the maximum number of this prediction vector and that's it. But now we are doing something that's very atypical. But let me show you what happens if we make this change. Let me show you the new confusion matrix if we do this change, and this is how it looks like. You can see that for the pneumonia category we are getting a very high accuracy. It's not really that high as it used to be, right? Now we are getting more mistakes, we are getting more misclassifications, but nevertheless this is a very good accuracy. In total, we have something like 390 images which were labeled as pneumonia, and 353 of those images are classified as pneumonia, are still classified as pneumonia. So this is something like 90% of the entire data which was labeled as pneumonia. This is a lot. This is a very high accuracy. But now if we look at the normal category, you can see it's not perfect. This is not as good as the pneumonia category. We are still getting many misclassifications, but nevertheless this looks much better than before. In the other confusion matrix, in the other one I showed you a few minutes ago, we had something like a 30% accuracy in the normal category, right? And now you can see that we are getting something like a 60%. If we make this sum, 162 plus 72, and now I divide 162 divided 234, we are getting a 69% accuracy. So this is much higher. This is almost a 70% accuracy. So it's not as high as the accuracy we get here for the pneumonia category, but it's very high nevertheless. So this is a much better improvement, and you can see that by doing this very small change, now we are getting a much better classifier, and we're getting a much more robust classifier. So this is definitely a very good improvement. And this is what I want you to take from this video. This is by far the most important part of this tutorial. Sometimes when you are training an image classifier, when you are training a machine learning model, sometimes things happen. And the way it usually goes, things happen. If you're expecting everything to be super smooth and super straightforward, then think again. Because when you are training an image classifier in real life or any type of machine learning model, things happen. And whatever thing happens, whatever problem it arises with your model, with your classifier, you need to provide a solution. You need to fix the problem. And in order to fix the problem, you need to be creative. You need to think outside the box, exactly as we are doing over here. So this is what I want you to take from this video. This is by far the most important part of this tutorial. So this is the change we are going to make in order to improve this classifier, in order to make this classifier way more robust. And that's pretty much all. And that's it. That's all. So the only thing we need to do now, before I forget, is to change the background, right? We are going to change the background for something a little more nicer, for something prettier. And let's do it before I forget, because this is such a detail and this is such a meaningless detail that I almost forget. So let's just import set background, and now let me show you the images I have in my local computer, which we are going to use in order to change this background. I have a directory which is called BGS, and if I open this directory, you can see I have many different images. These are some images I have been testing when I was preparing this tutorial, and let's just use this one, which is bg5.png. So let's go back to PyCharm, and I'm just going to say set background, and I'm going to specify the path to this image, which is bg5.png. And that's pretty much all. Now I'm just going to refresh, and you can see that now it looks much better. It looks much nicer. It looks much prettier. I'm just going to test it again. Let's try with another normal image, maybe something like this. We should be getting something like a 70% accuracy, so we should be getting this image classified correctly as normal with a 93% accuracy. So you can see that everything looks pretty well, and that's going to be all for this tutorial. My name is Felipe, I'm a computer vision engineer, and these are exactly the type of videos and the type of tutorials I make in this channel. So if you enjoyed this video, I invite you to click the like button, and I also invite you to subscribe to my channel. This is going to be all for today, and see you on my next video.